Okay. How's everyone doing today? Good? Good. I haven't seen you guys yet this week, so it still feels like the weekend is just ending. It's just a big quirk in my brain. And I'm already thirsty. Hope you guys are all having a good day. Maybe the first time this class meets this week, but the week is still nearly halfway over, so that'll be nice. Usually on Wednesdays, we will be wrapping up homework assignments. I'll answer any questions that you have about the one that we just ended. I'll collect it and I'll give you the next one. We'll at that point begin learning everything we need to about it. It's just I want to give it to you as soon as the old one is handed in so you can start on it sooner. That said, this first week is just a little weird because we had to spend first syllabus, so things are kind of offset by a day or so. Additionally, I didn't realize till about 10 minutes ago, I forgot my laptop at home with all the files and homework on it. So I don't have the next one to give to you today. So today, we are going to dedicate ourselves entirely to working on our first assignment together and finishing it up. So, when we are doing the classwork portion of the homework, I do encourage you guys to interact with each other. You don't have to be talking to me or with me the entire time, but I will be up here working, setting up examples with you guys based on what questions you have. So I encourage all of us to work together, and before, excuse me, right to start with, are there any big lingering things that you guys noticed during this assignment and think are particularly troublesome to look at? The logarithms might be a good example.
We worked on number 8.
Number 8. Yes. Okay, yes. So let me just find the marker that still has ink in it. All right. So this is number 8. This is the last question in the solve for x, the first solve for x SAT section. And number 8 is unique in this section in that it has an x in it more than once. Now, in algebra in general, if one letter repeats, it's considered to be the same variable across both iterations. That means that you can combine them like they are like terms. They can be combined through various methods like the distributive property. So, in this type of example, since our end goal is to get to x equals blank, we need to get both of the x's on the same side and combined. So, we have a positive 8 times x over here, a plus 3 without an x, and on the other side, a positive 9 times x, and a negative 2 being subtracted from that. We want to get both of the x terms on one side, and it doesn't really matter which side you choose. That said, since this one is being multiplied by the bigger thing, when I look at this, my first instinct would be to try to subtract this term over to this side, because that'll prevent us from generating a negative in a second. Is everyone okay with that step? Does anyone not okay with that step? Let me ask it like that. Okay, so even though it has an x in it, we can still add, subtract to the other side like anything else. So minus 8x, minus 8x, and that'll give us 3 equals 9x minus 8x minus 2. Both of these have an x in it. That means that they can be added, subtracted together. This only works if all of the variables within 2 terms are identical though. So it's, both of these are some constant times the x term. But if one of these was like 8xy, suddenly we couldn't add them together. It's only if they are identical in terms of what variables are present. But we can't, because these only have just the x, we can just add them together. So what's 9x minus 8x?
X.
Just x. And we're one step away. What should our x equal to?
5.
Yep, positive 5, because we want to add this, we want to add 2 to both sides. That'll give us 3 plus 2 equals x equals 5. And if you're ever nervous about an answer like this, if you did the work, if you think that number can't be right, you can always put your answer back into the original and check. So just brief exercise there. 8 times 5 plus 3 equals 9 times 5 minus 2. 8 times 5 is going to be 40, plus 3. 9 times 5 is 45 minus 2. Both of these sides should equal out at 43 as advertised. Very good question. Thank you guys very much. Any others that are causing big problems right now? Yes.
It's been a minute since I've messed with math, other than statistics, which is never math. So on the ones without numbers, I don't know really how to even start, like number 12.
Yes, number 12 is a doozy, simply because it just has so many things in it. 12 is a very specific formula that you will encounter in physics. This entire section here, 9 through 14, are physics formulas that you will see again. Some of them not for a while though, because 11 and 12 are both pressure, and that'll be in your second semester of physics. Here's my eraser. Thank you. I need more erasers, but another student told me I should just keep it in my pocket, which has kind of changed my life when I remember to do it. And so because I'm going to erase this, and we will look at 12 together. 12 looks intimidating just because of all the stuff in it, but it's the hardest part is just writing it all down line after line. To actually get where we want to go in this, it's not the worst. The writing's the hardest part on this. So, let's start writing. P1 plus little weird P letter times PGH1, and might as well go ahead and talk about it. If you notice that the small p's in this formula don't look like a normal script English P, it's because they're not. It's actually a lowercase Greek rho, and that stands for density. So I may refer to it as rho in the rest of this example. Plus 1/2 rho x squared equals P2. The two big ones are normal English P's though, it stands for pressure. Plus rho GH2 plus 1/2 rho V squared. Now, this particular big scary formula, when you will eventually start using it normally in a couple of semesters, is about looking at the different things that contributes to pressure in the system, be it air pressure or liquid pressure. And our goal for right now is just to get x equals blank. So, this is the one term present that has x in it, which means we need to get rid of everything else on this side so that we can then begin operating here. So, using SATMEP, we should get rid of these things and send them over. Sorry, I don't know what I was trying to say there. Do we agree? Does anyone disagree? Okay. So, if I may, save a little bit of time and writing space. I'm going to try to subtract both of these in one fell swoop. Which should give us something to the effect of 1/2 rho x squared equals B2 plus rho GH2 plus 1/2 rho B squared minus B1 minus rho GH1. We concur? Okay. It is long, but now that all this is on the other side and there's no x's left in it, we don't really have to do much else to it except what's going to come over from the other side to get x by itself. So we need to get the 1/2 over. How would we do that? We can just multiply both sides by 2. You get this row over. You can divide both sides by row. And then you want to take the square root of both sides. So the final answer is going to look weird. It's going to be long. And I'm not expecting you to put any time into simplifying it. It's supposed to be, it's going to be a big mess no matter how much work you put into it. So as soon as you get to x equals square root of blank, that's fine, you're done.
When you multiply the 2 on both sides, it cancels out on both sides, right? Is this another 1/2 on the other side?
Not entirely. This 1/2 is only being applied to one term. So if you were to multiply both sides by 2 to try to cancel out this 1/2, this 2 is being multiplied by the entire right side. So it would get distributed in to every single term. If you did that, you'd end up with 2b2 plus 2 rho GH2, 2 times 1/2 rho b squared. That would simplify just to rho b squared, but the 2 is going to be applied to everything. I would also accept just leaving it undistributed 2 times, open parentheses, everything. Similarly, when you divide this row to both sides, it is acceptable to just leave everything on top of row and then take the square root of the whole thing. So that would look something like this. So what we're doing isn't necessarily that bad. It's just there's too many letters. Yes.
So would it be okay if we just did the square root and just leave it like that? Just like
Yes.
square root.
I'm absolutely fine with that because it would all be inside of the square root. And there's no good way to simplify it. You could divide every single term by row to try to simplify some of these rows out. You could bring the 2 inside, but that's not going to cut down on the number of letters you need to write all that much. So if you get this, you can leave it. This is an answer. You have x equals blank. I'm satisfied there. I've already written this problem enough. Okay. Any other specific questions? If not, I'd like to talk a little bit about the logarithms, because I think I introduced that at the end, and they still might look pretty alien if you haven't used them in a minute. Yes?
For 20, are you just looking for like the 8th root of 64?
Yes. Which there is a way to put into your calculator. Granted, I would just accept 8th root of 64 there, but since our next lesson is going to be about how to use all the advanced calculator functions, at least on my model, you press the math button, it brings you to a bunch of things that didn't fit on the keyboard. To do a root that isn't second, so specifically with 20, we would end up with x equals the 8th root of 64. There's no 8th root button on the calculator. So what you do is you want to scroll through your math menu and find a button that's x square root. If you press that, and you put a number in front of it, the x absorbs that number and this becomes 8th root. So you can then do 8th root of whatever you want. And that would give you an integer answer, which will be coming up on the next homework when we dive into the bigger functions of this thing. Or whatever your model is. Make sure you have one of these ASAP. Or not, again, it doesn't have to look like this, because this thing's 15 years old. But it does need to be a scientific calculator. Yes, sorry.
Can we do number 17 and then 18?
17 and 18. Yes. 18 is a good one, because that's also a physics formula that you're going to deal with a lot in the next couple of classes. Start with 17. Oh, this one also has multiple x's in it. So thank you for pointing it out. I didn't remember that one. Okay. So again, we need to get x equals blank on one side. So we have 3x over here, and then 1x in the denominator of the other side. We need to get it out of there. Leave them both on one side. So what single operator would get that x out of this denominator where it clearly doesn't need to be? Sorry. Very good. So we can multiply both sides by x. I'll write that full step out. So we multiply both sides by x. That's going to cancel the x in this numerator, and it'll put 1 on the other side here. So the left will simplify to 5 plus 7 to the third. And then this, on the right, we have 3 times x times x. That can be simplified. What is x times x?
X squared.
Very good. So this side just becomes 3 times x squared. Does that look a little more manageable? Start putting 18 up here. This formula is the kinetic energy formula, which will come up a lot in a lot of your science classes actually, because when you study chemistry, and you're talking about thermal energy inside of gases, thermal energy is just kinetic energy on the subatomic scale. So, important concept. And this technically, since this was written by a physicist, Ke is one variable. This is the symbol for kinetic energy. It doesn't matter supremely when doing this particular question if you're just trying to get to x squared, but this is one combined thing. This is not K times E. That was not the intention. So just to make you aware of future developments. Again, we want to get x by itself. There's nothing being added or subtracted to the term with the x in it, so we should be able to start simplifying things over to the other side. The x squared is being multiplied by 1/2 and by m, so we can begin multiplying and canceling things, try to get what we want. Does this make more sense now? Yes, sorry.
Can I do, number 19?
19, yes. Okay. So this also has a lot of terms in it. And I'm not especially proud of it if you work simplifying them or not. Our goal is just to get x equals blank. We have t squared equals 4 pi squared times g times m times x to the third. So this whole thing is the one term that has the x attached to it, but thankfully, this one x term is only being multiplied by all this. The x is technically in the numerator, so we don't have to fish it out of the denominator. All we need to do is just get rid of all this stuff and send it over, and that'll give us x to the third equals blank. We can take the cube root from there. And since this term here, the x to the third, is being multiplied by what amounts to a big old nasty fraction, we can probably cancel it out in one fell swoop. How do you think we can do that? Very good. So we're just going to multiply both sides by the reciprocal of this thing, which would be gm on top and 4 pi squared on the bottom equals 4 pi squared over gm times x to the third times gm times 4, sorry, divided by 4 pi squared. And that will all at once cancel out that whole fraction and leave us with x to the third equals gmt squared over 4 pi squared, which I will simplify what's on the board, just make it look a little nicer. That just looks like a time zone. Okay, and so to get x equals blank, what would our last step be?
Cube root.
Cube root of both sides. And when you apply cube root to this, you can leave it as is. Your work is done. could do it one piece at a time. It would just take up a lot of lines in my board. But since this fraction is just multiplying by, you could send them one over at a time if you were more comfortable with that. Yes?
Can we look at, I know you want to look at logarithms, can we look at 23?
We can. So I'm going to go back to the other side of the board and start putting up some information about all of these logarithms. Now, in the notes that I showed you last time and that I have uploaded to the Brightspace classroom for this class, there's a little table that shows all of the log functions and all of their inverse operators. Because all of these functions, the weird little e, log, ln, they are all just operators, kind of like square or square root. So when you look at your calculator, you have buttons for log and ln. There's a separate button somewhere for the e. And since they are operators like square to square root, it means they also have inverses that you can use to cancel them out. And that's what these problems are. So, as a brief refresher, this is in your notes, but those operators are, to list them in the order they appear on the home page. If you have something equal to e to the x, the inverse of that operator, this little e is the natural root. It is its own weird number, kind of like pi. So this is a constant number to the x power, but we need to get that x down. So what we do there is the inverse operator is the natural log. Yes, that's it. And if instead of e you are raised to the power of 10, the inverse is almost the same, except you will use normal base 10 log instead of ln. And I do want to work some of the examples to show these steps one at a time, but these are the operators if you haven't written them down yet. So, I was specifically asked about 22 and 23. So let's take a look at those together. I'll put that board over. So 22, 900 is equal to 10 to the x power. We need to get that x down. So what we're going to do is, since the x is being raised, since this 10 is being raised to the x, we need to look over here, and we want the inverse function we want to use is normal log base 10. This is kind of like how your calculator assumes most roots are square roots. Most normal logarithms are base 10, which means that it can negate this 10 here if we apply this operator correctly. So, whatever we do to one side, we have to do to the other. So we are going to perform log base 10 on both sides. And this is the part here that's kind of like squaring a square root. If you do log base 10 on 10 raised to the anything, these two things cancel out and the power comes down as its own number. So So the final answer would be log base 10 of 900 is x. And the same thing would work in reverse. If you have an x in here, you can raise both, you can set 10 with it. See, I can visualize it, but I haven't had to describe this part in words in a second. Yeah, let's just look at 23, because that has what I'm talking about in it. So in 23, we have some constant beta is equal to 10 times log of x over IO. So, because there's log, and if there's no like little symbol right here, if there's no number or anything, you can always assume that it's log base 10. What we're going to want to do is raise these over 10 in a second, but before we do that, we should probably send this 10 over to the other side first. So we'll have b over 10 equals log x over IO. Now, we're going to do the inverse of what happened over here. We're going to, instead of performing the logarithm operator on both sides, we're going to raise both sides as powers over 10. And that's legal as long as you do it to both sides. This side will remain as it is. Nothing here further cancels, even though it might look like it does. But then on this side, the 10 and the log cancel, and that's just going to spit x over IO out by itself as a normal number.
Do you leave it like that?
We want x, so there's one more step.
So it multiply?
Yeah, we want to send the IO over. Out of all these, I'd say these are the ones that are the least straightforward, so it's okay if you still need a second. Yes.
Well, where would the IO go after you multiply?
Sorry, one more time.
Where would the IO go after you multiply?
Good question. So on the left side, we have 10 raised to the something. On this side, it's x over IO. We want x by itself, so we need to multiply both sides by IO. And you'd be multiplying IO times 10. The 10 just happens to be raised to a power. So go ahead and put the answer. So this term times IO, other side times IO. And if I would write this to, say, put it into a calculator without confusing anything, I would do IO, open parentheses, 10 raised to the beta over 10 equals x. The IO is being multiplied by the whole of 10 raised to the beta over 10. And that doesn't simplify any further. That's your answer. When you do 24, it works the same way as this one, except instead of raising things to the 10, you're going to raise, instead of putting things as a power over 10, you're going to put them as a power over the weird little e, since that's what cancels with the natural log. How we feeling? We've talked about some of the biggest ones in each of the individual sections, so since we're closing in on the end, just to go ahead and make some closing statements as we get near the end of the period. This assignment, I think I already said I'll make it due next Wednesday, just to get in the habit of having them do a class every Wednesday. So that'll give you some time to just talk amongst yourselves, wrap things up. We also have some time to get together, continue working on it. Friday, I'm going to go ahead and give you the next assignment on Friday. That's just so that you can have it and start looking at it as soon as you're done with the other one. It won't be due until a week after this one is due, at the earliest. And what we'll be covering together on Friday is advanced calculator functions and working through those problems together. But I'd say you guys have this one in the bag at this point. If any of them still look scary, let's still go over them together. But I feel comfortable that you guys have everything you need. So for the rest of the period, please continue working on this as long as you want to stay. If you feel comfortable, I'm not going to hold you here since the rest of the class is just working together. But keep working with each other, with me, ask me questions, and that'll just be it for the rest of this period since I don't have my laptop to do the next assignment today. Sorry about that. That one's entirely on me. I will never let my mistakes make an assignment harder for you guys. Yes?
For 24, is it okay to put like a 6 attached to the exponential number, or can you not do that?
You can.
Can
So
you just
kind
go
of like
over
here, eventually you'll multiply a 6 over to the other side. You can multiply 6 by e to the 52. It's a weird term, but it is its own self-contained term. You could, if you wanted to, go to your calculator and find what it is. E is kind of like pi. It is a number. It has a set value. I can just never remember what it is because it's a weird little fella.
It's right here.
Yes. If your calculator is at all similar to mine, you might have a ln button, which performs the natural log function. My little e symbol is the secondary function of that button, which kind of forms the two are inverses. And you could put, it would end up being e of 52. It gives you a number. It is an answer. It's just a really weird one. Yes, sorry.
Can you just go over it?
Yes, I can. Because that one does have a few extra steps after you get the term down. I've been doing this type of math for so long, I can visualize it all in my head, and it takes me a second to realize that not everyone can do the same thing. This is what I'm literally paid to do. Okay, so let's just take a look at 24. 52 equals natural log of 5, well, that's 5 plus x, not 5x, over 6. So our x is buried inside of this ln function, which means we need to dissolve the ln function first to begin pulling that out. So to dissolve an ln, we need to raise both sides to the we need to make them both a power over e. And to do that one step at a time, e to the 52 equals e to the natural log of 5 plus x over 6. So this whole thing is a power over e, the 52 is a power over e. And these operators will do what they do and cancel out, which will spit this whole variable term here, 5 plus x over 6, out as its own term, not raised to anything, or not over anything. Which would give us e to the 52 equals 5 plus x over 6. You could put this in your calculator to get a number, if you just wanted to make it a number. However, that number is 3.83 times 10 to the 22nd power, which I don't think saves any writing time ultimately. So this may stay as it is, if you prefer. This whole thing is just a term, so you can put parentheses around it. It's its own contained thing. You can multiply something by it and leave it something times what it is. So you don't have to simplify it any further than this if you don't want to. We do need to get x by itself though. What's the next thing to undo over here to accomplish that? Very good. Multiply both sides by 6. And that will leave this side as 6 times e to the 52. This can be left as is. This is an exponent. That's going to be applied to the e no matter what. Whatever this big number is, it would then be multiplied by 6. So mathematically, this is fine as it is. There's nothing else to do there. That'll leave us with 6 times e to the 52 equals 5 plus x. One last step to get x by itself. How bad is my handwriting today? I'm especially self-conscious about my 5s and my 2s because they always end up looking like S's. Also, I'm aware that my G's look like 6s. I mean, most do, just mine especially so. There's one more on here that might be particularly troublesome. How about we take a look at 13? Is that what you can ask about? Okay. 13 is another real formula that will show up in your scientific career. This particular formula refers to the Doppler effect. You may have heard of Doppler weather radar, which uses the same physics principle. This doesn't stick. I don't know why I bother trying. So F, observer, is all one term. That's just F with a subscript. And similarly, F, source, is all one term as well. Open parentheses, V sound plus X over V sound minus V source. So this particular formula talks about the change in the frequency of sound you will hear based on whether or not you are moving or the source of the sound is moving. We got two different frequencies here. This is what you actually hear. This is what the original object produced that is being offset by velocities, the velocity of you or the machine that created it. Now that's a lot of words and we haven't talked about sound yet, but to at least put something you have heard of this before, have you ever heard, or recall if you've ever heard an ambulance pass and it sounds like, That's the Doppler effect. The frequency changes based on whether or not it's moving towards you or away from you. And this is the formula that changes the frequency depending on those. Our goal is to get to x, and it's pretty well buried in here, so we need to start canceling things out. X is in the numerator of this fraction, whole thing being multiplied by f source. What's the first thing we should try to send over?
Yes.
Very good. For simplicity's sake, I'm probably going to simplify that to FO and FS. Nope, I can't do that because the others don't simplify as well. I'll keep them the same. And that'll be equal to V sound plus X over V sound minus source. Oh my gosh. V source. There we go. So, X is in the numerator. What's our next step?
Could you just multiply by the V sound minus V source?
Right. These together are both being divided by this, and they're kind of a lump sum. If we divide both sides, if we multiply both sides by something, it has to be by both. So these combined things are now going to be one term. So we're going to multiply both sides by, open parentheses, V sound minus V source, closed parentheses. Other side will be V sound minus V source, close parentheses for 1. Those cancel. And that will leave us with V sound minus V source. I'm sick of writing these words already. This is probably why in my own, when I'm doing my own research work, I try to plug numbers in as soon as possible. So you cancel out the denominator, that just leaves us with the whole numerator. One more step to get x by itself. We can subtract V sound over to the other side. And you can leave this unsimplified. It's okay if the answer is just this and then minus V sound. Because I don't see a very good way to simplify that further. Not effectively. I think I thought this went fast, so. Any questions about anything on this assignment or that we've talked about so far? Yes?
Number 20, you went over it, but I'm still confused on it. You said that we could get to a certain point and plug in the calculator, or we should remove it? I can't remember.
It's okay. So the period is over. You can start packing up. I don't want to keep anybody if you already have this one. But just in brief, if you want x by itself, the same basic thing as x squared, where you take the square root of both sides. It's just now we want the eighth square root of both sides. So just like the square root of a square cancels, the eighth root of an 8 cancels, which leaves us with the eighth root of 64 equals x. On your work, this is acceptable. But this is a number you could find with your calculator, like going into your calculator, typing an 8, finding the x root button, putting 64 in there. So you could get this number. It's going to be pretty small. For your homework, you can leave it like this. Thank you all. I will see you Friday, where we will begin talking about the next assignment. Have a great day.